So electromagnets are very simple, and it's a very common science experiment done in elementary schools across the country. You have three components that make up an electromagnet, and they've been used in automobiles from the very first internal combustion car to the modern day Italian supercars. And that's from Danish from 2007. Electromagnets are very common in everything from engine management systems, emission systems, and safety systems like ABS. And despite almost everybody having built an electromagnet at some point in their life, we're going to discuss how they work. Electromagnets are, again, made in three parts. You have an iron rod that acts as the magnet. You have a solenoid, or a coil that's wound up, typically copper, and then you need current flow, or electrons moving from negative to positive. When the electrons move from negative to positive through a solenoid, it creates a magnetic field, and the iron rod is used to channel that magnetic field and become a magnet. Now, electromagnets used in automotive are everywhere, and in engine management systems, a common electromagnet is in the fuel injector. Now, the fuel injector has a coil winding, not permanent, this one is more of an active or moving iron rod called the pintle. And so when you have current flow provided through the engine computer, through the coil winding, it will move the pintle up, allowing fuel to spray into the engine. This is what it looks like graphed out voltage over time and amperage over time. So you can see the voltage drop, or the voltage is being used as our amperage builds. And then when our amperage drops, the voltage spikes as the pintle opens. And then in our amperage, you can see another secondary spike, and that is the pintle moving back down, closing the fuel injector. So as part of the functions of the electromagnet, when you have an iron core that moves through a magnetic field, it will create voltage as well. Another common use case for the principles of electromagnets is in ignition coils. Again, when you have a magnetic field that collapses through a solenoid or a winding, it will create or induce voltage. In ignition coils, there are two windings present in the coil. You have a primary, which is in relation to the secondary, very few windings. We have current flow that's controlled through the engine computer to build up a magnetic field. The computer then cuts the current flow, causing that magnetic field to collapse through the secondary winding, inducing between 80 and 120,000 volts. And then this is similar to the fuel injector. This is our voltage over time and our amperage over time of an ignition coil. And now you have fuel and you have spark, but for an engine to run, they have to be at the right time. So what we do for that, we still use the principles of electromagnets. And the way that works is we have a electromagnetic sensor and a tone wheel on the rotating assembly of the engine. And so the way that works is you have a magnetic ring with permanent magnets at a specific pattern in it. And then as it rotates, it passes by a sensor that has the coil winding in it, inducing voltage in the sensor, which is read by the PCM, or the engine computer. And that's how the computer knows where every component is in the engine and knows when to fire the fuel and when to light the spark. And this is a reading off of one of those sensors. We also use electromagnets in safety systems like the anti-lock brake system. The way that works is very similar to the cam position sensor and the crankshaft position sensor, and then that the wheel hub has permanent magnets embedded in the back. And there's, again, very, very similar, so I'll use the same picture, a coil winding and a sensor. And so when the wheel spins and the permanent magnets pass by the sensor itself, it will induce voltage in AC, and the computer can determine the speed of the wheels based on the period of the sine wave. So the closer the sine waves are, the shorter the period, the faster it's moving, and it can then interpret that as wheel speed, and it compares all four wheels together. So if one wheel starts to slip, it can apply brakes in however it needs to keep the vehicle from sliding it up at a very aggressive stop. So with these concepts of electromagnets and how they work in a much more complex system like a car, again, these are only a couple of examples. You have electromagnets in the emission systems that help keep the air clean. You have electromagnets that lock and unlock the doors. And you even have electromagnets in, like, say, again with the ABS system, in the pump that controls the brakes. So whenever they need to make adjustments, there's an electric motor that uses the same principles of electromagnets to push fluid to the brake calipers to stop and start and kind of grip. That being said, the principles of electromagnets, while very simple in concept and how they work, can be used in much more complex systems, and it's important that we don't forget the small, simple things when we look at big systems as a whole, and it's nice to kind of see and relate to, or even have this new information on something that you use every single day of your life that you don't even think of. Thank you. Good. I lost the plot halfway through.